Alrighty, so today we're going to be talking about solving quadratic equations. And we have actually talked about a couple ways already. Okay, the first way was factoring, okay, and factoring using the zero product property. And then the second way is graphing. And remember, the solution for graphing is the x-intercepts, and we'll talk about that in a little bit. Okay, so let's kind of refresh our factoring. Okay, this is a trinomial. So to do a trinomial, we always listed our A, our B, and our C. So in this case, remember, this always follows our standard form. So ax squared plus bx plus c equals 0. So our slip, slide, and divide. So A is 2, B is a positive 1, and C is a negative 1. Okay, and then we did our A times C. So A times C, so 2 times negative 1 is negative 2. And we're going to list the factors of negative 2 that add to BB, which is 1. So what times what is negative 2 that adds to be 1? And I'm going to say 2 and a negative 1. So these are our factors we're going to use, and they go inside our parentheses. So x plus 2, x minus 1. And then our last step, remember, after we put them in there, we have to divide by our A. And what is our A? 2. And can I divide 2 by 2? Yes. So I get x plus 1. 1/2 I can't divide, so I pull the 2 out in front of the x, and I get 2x minus 1. So now we are factored, but we haven't actually solved for x yet. So this is where that zero product property came on, and we set each group equal to 0, and we solved. So the first one would be x would equal negative 1, so you subtracted the 1. And then here we would add the 1, so we get 2x equals a positive 1 divided by the 2. So x would equal 1/2. So x could either equal negative 1 or 1/2. And if I put negative 1 in for x, we would get 0. And if I plugged in 1/2, I would also get 0. So here are our two answers. Okay, and that was back in chapter 7 we learned that. Okay, the second way, which actually is a lesson here, is 9.2. It's solving quadratic equations by graphing. And we've already learned how to graph, so I'm not going to go too far into this. And once we graph, okay, our solution is actually our x-intercepts. Or as we factored, this negative 1 and the 1/2 are our x-intercepts. So those would be our solutions. Okay, so let's refresh our graphing. Okay, the first one is standard form, which is like how we factored, which is that y equals ax squared plus bx plus c. And our axis of symmetry is where that equation that splits our parabola in half, and the axis of symmetry was x equals negative b over 2a. And then the vertex, the x-coordinate is always the axis of symmetry, so that negative b over 2a. And to get our y, remember, we plugged it in and solved for y. So we plugged in our x, solved for our y. Vertex form here, okay, was y equals a times the quantity of x minus h squared plus k. And in vertex form, it gave us our vertex. H always lies, so it's a positive h, comma, and k tells the truth, so a positive k. And the axis of symmetry is x equals h. And then intercept form was y equals a times x minus p times x minus q. So intercept form was also known as our factored form. And that was the only one that didn't have the x squared, because if I FOILed this out, we'd get the x squared. And in this case, we could find our x-intercepts. And our x-intercepts, because they're inside the parenthesis, they always lie. So it's p and q. So to find our axis symmetry, it was always the middle of our intercepts. So x equals p plus q divided by 2. That would find our middle. Okay, and then our vertex, we know our x-coordinate because that's our axis of symmetry. And then how do we always find our y? We plug it in and solve for y, following orders of operation. And then once we graph those parabolas, the actual solutions, as we said, is the same thing as like finding your roots, your zeros, or the x-intercepts. So if it asks you to solve by graphing, you graph the function, and then you just state your x-intercepts. So x would equal -1, and x would equal 1/2. And I just use the same answers as we did for factoring. Okay. So that would have been 9.2, graphing the quadratics, stating the x-intercepts. Okay, we're going to go ahead and skip that now. All right, so 9.3, what we're going to do is we're solving these quadratics, so we're going to do a new way using square roots. Okay, now when we look at using square roots, we can only use square roots in the form of ax squared plus c equals 0. So if you notice, there is no bx. So the only time you can use square roots is when there is no bx here. Okay. Now, do we know how to solve an equation? Yes, we do. Okay, that's what we're going to be doing in this sense. We're solving for the x squared. Okay, so the first thing, if I solve for x squared, okay, we end up getting like x squared equal d, which d represents a number. Okay, if that number, if x squared equals a number greater than 0, meaning it is a positive number, we are going to have two real solutions. Okay, and those two real solutions is going to be plus or minus the square root of whatever d is. Okay, so like if I had an example of like x squared equals 4, to get rid of a square, we take the square root. So since 4 is positive, we're going to put plus or minus, and the square root of 4 is 2. So x could equal be a positive 2 or a negative 2. Because think about this. If I plug in a positive 2 and square it, I get a positive 4. If I plug in a negative 2 times negative 2 is again a positive 4. Okay. Now, when d equals 0 now, so if we have an example of x squared equals 0, when I go and take the square root of both sides, are we going to have a positive 0 and a negative 0? No, 0 is just 0, so x would equal 0. So we're only going to have one real solution, and that real solution is 0. Okay. And then the last one here, when d is less than 0, so meaning d is negative, okay, let's look at a problem like x squared equals a -9. When I go and take the square root of that, can I take a square root of a negative number? No, that is not possible. So we have 0 real solutions, meaning we have no solution. And what that actually means is if we graph this, our parabola would never cross the x-axis. Okay. The first one, when we had 2, that means we had 2 intercepts. So my parabola crossed it twice, the x-axis twice. When d is 0, we only have 1, so it only hits it at one spot, which means it's our vertex. Okay. And then if d is negative, we have 0, so it would never, ever, ever cross the x-axis. Okay. So how do we solve this? Okay. So the first thing is we're going to solve our equation for x squared. So we add or subtract our constant, we move our coefficient by multiplying or dividing. Okay. Then we're going to get rid of the square. So get rid of x squared, get rid of the square by taking the square root of both sides. Make sure when you take the square root of both sides, you determine how many solutions are there. So do I actually have to put a plus or minus? Do I just have the one answer, which is 0? Or do I have no solution, meaning it was negative? Okay, so let's go through this. right, so example 1, solving for this 3x squared. So how would I move 27 to the other side? I would add 27. So I have 3x squared equals 0 plus 27 is 27. And then I need to get rid of this coefficient. So how do I get rid of the 3? I'm going to divide it. And I get x squared equals 9. Okay. Now, x squared is by itself, so we need to get rid of the square. So we're going to take the square root of both sides. Okay. Now, since 9 is positive, we're going to have two answers. So we're going to put plus or minus. And what's the square root of 9? 3. So once again, that means my x could be positive 3 or negative 3. Okay, so you could either write it as plus or minus 3 or x equals 3 and x equals negative 3. Okay, so my parabola would cross the x-axis at 3 and negative 3. Okay, let's go ahead and do number 4 here. So solving for this negative 5x squared. So how would I move a positive 11 to the other side? I would subtract it. So I get negative 5x squared equals 5. And then how do I get rid of the negative 5? I'm going to divide it because it's a coefficient. And I'm going to get x squared equals negative 1. Now, to get rid of a square, I'm going to square root both sides. Now, because this is negative, can I take the square root of a negative number? No. So we actually have no solution in this problem. Okay. Moving on. All right, looking here. Okay, solving for our x squared. How do I move a minus 10? Well, I'm going to add a 10. So I get x squared equals negative 10 plus 10 is 0. Okay, there's no coefficient, so we don't need to get rid of it. But now we get rid of the square by taking the square root. The square root of x squared is x. And can I take the square root of 0? I can, but we do not have, since that's 0, we don't have a plus or minus because 0 is not positive nor negative. So x would just equal 0. So meaning it only hits our x-axis at one spot. All right, looking at number 3 here. Okay. Solving for 6x squared. Okay, move our constant of 13 to the other side by subtracting it. So I have 6x squared equals a negative 4. And then how do I get rid of a 6, the coefficient? I'm going to divide by 6. And I get x squared equals, now negative 4 over 6 simplifies to negative 2 over 3. And then we're going to go and take our square root. Now, underneath our radical, the radicand is negative. And can I take the square root of a negative number? No, I cannot. So my answer is no solution. There you go, good. All right, looking at 5 and 6 here. These are a little bit different because we have quantities that are raised to the square. So if we have the quantity raised to the square, we need to isolate that quantity squared, which in number 5, that quantity squared is isolated. So we don't have to solve for it, okay? So now we can get rid of that square by taking the square root of both sides, okay? Now, the square root of the quantity of x minus 1 squared is just x minus 1. If you've noticed, taking the square root always got rid of the square. So same idea here. Now, this 25 is positive, so how many answers do we have? We have 2, so we're going to take the plus or minus, and the square root of 25 is 5. Now, we have to solve for that x, okay? So how would I move, how would I move that minus 1 to the other side? I'm going to add it. And this is where you have to think here. We have two answers, right? We have a positive 5, so I'm going to take a positive 5 and add 1. And we also have a negative 5, and we have to add the 1, okay? So 5 is positive and negative, so we have to look at a positive 5 here and a negative 5 and add 1 to it, okay? So a positive 5 plus 1 is 6, so there's my first answer. And then a negative 5 plus 1 is a negative 4, and that would be my second answer. Now, looking at number 6, we have to isolate that quantity squared. So if you look at here, the quantity squared is x plus 3 squared, but we still have that 2 on the outside. Now, I cannot distribute the 2, so do not distribute. And the reason why you cannot distribute is because if you think of orders of operation, wouldn't I have to square it before I multiply? So what we're going to do is we're going to get rid of that 2. And when you think of distributing, you think of multiplying. So how would I get rid of multiplying by 2? I would divide by 2. So I'm going to divide both sides by 2. These 2's would cancel, and I'm left with that x plus 3 squared equals, and 18 divided by 2 is 9. Now, if you look at my quantity is isolated. So how would I get rid of a square? I'd take the square root of both sides. And the square root of the quantity of x plus 3 squared is just x plus 3. 9 is positive, so we're going to have 2 answers. So we're going to have a positive and a negative, and the square root of 9 is 3. Now we have to solve for this x. So how do I move a plus 3 to the other side? I'm going to subtract it. Okay. So now we have to think about this. Is x plus 3 equal to a positive 3 and x plus 3 equal to negative 3? So now we have x equals a positive 3 and a negative 3, and we subtracted this 3 to both sides. So we're going to subtract 3 to both of those. So 3 minus 3 is 0, so that would be my first answer. And negative 3 minus 3 is negative 6, so that would be my second answer. Okay. Alrighty, and then number 7, I left, okay, after those ones, because you'll see here in a second. Okay, now, we're back to not a quantity being squared, but just x being squared. So let's go ahead and solve for x squared. So how would I move a minus 4? I'm going to add the 4. So I have 3x squared equals 20 plus 4 is 24. And then how would I get rid of the 3? I'm going to divide by that 3. So I get x squared equals 8. Good. And then how do I get rid of a square? I take the square root. And 8 is positive, so I'm going to have how many answers? 2. So x equals plus or minus. Now, what is the square root of 8? We don't know. Okay. So in this case, right now, we have the square root of 8 plus or minus the square root of 8. But here, we can simplify this, okay, to get an exact answer. So do we know how to simplify the square root of 8? Yes, we do. That's what we learned in 9.1. So we're going to break down 8. So 8 breaks down to 4 and 2. 2 is prime. 4 breaks down to 2 and 2. So 8 would break down to 2 times 2 times 2. Now, because it's a square root, we look for squares, pairs. So I see a pair of 2's. So I'm going to circle a 2. I'm going to cross a 2 out. So the 2 comes out. So x would equal plus or minus. The 2 comes out, radical, and what is left under? 2. So my answer would be positive or negative 2 radical 2. Okay. Now, if you guys have any questions with any of this, please let me know.